talking trigonometric functions of any angle. And the goal is to find the 6 trig functions of any angle. In other words, in the next 2 sections, actually, we're going to extend the idea of SOHCAHTOA to angles that aren't just acute. So let's, before we talk about that, talk about what it means to be an angle in standard position. So you guys are familiar with the XY plane, right? So the upper right-hand corner of the XY plane is called quadrant 1. And then if you go around counterclockwise, quadrant 2, upper left corner, quadrant 3, lower left corner, quadrant 4, lower right corner. So an angle in standard position, well, if you let the initial side of the angle coincide with the x-axis, and the terminal side be somewhere in this xy plane, then this angle theta is in standard position. So in other words, the standard position of an angle is an angle coordinatized in the xy plane. Now, as long as you sweep out this angle in a counterclockwise motion, theta is positive. If you go clockwise, then theta is negative. Okay, so how do we define the 6 trig functions of an angle that's not acute? Well, first we have to coordinatize it. So let's put the angle in standard position. Okay, so we've got the initial side on the x-axis and the terminal side. In this case, it's in the second quadrant. That makes this angle, that's the one we're focusing on, call it theta, that makes it obtuse. So we're going to define the trig functions of this angle by creating a triangle. How do we create that triangle? Well, we'll go ahead from any point on the terminal side, doesn't matter where, it's just got to be on the terminal side. We'll drop a perpendicular down, in this case down to the negative x-axis. And that will change whether we raise a perpendicular or drop a perpendicular, depending on which quadrant the terminal side is in. And now we've created a triangle. Does everybody see it? So we've got this triangle here. And I'm going to call the side opposite theta, in this case, this side here, I'm going to call that y. And then we can still consider this side down here. We can consider this the side adjacent to theta. I'm going to call that x. And then the hypotenuse, it's going to lie on the terminal side of the angle. I'm going to call that r. And then I'm going to define the 6 trig functions in the same way I did for an acute angle. So once again, the sine of theta is going to be y over r, or if you like, the SO part of SOHCAHTOA, opposite over hypotenuse. The cosine of theta will be defined in the same way as before. X over r, or the CA part of SOHCAHTOA, CAH, which stands for cosine equals adjacent over hypotenuse, x over r. Tangent of theta, TOA, tangent of theta will still be opposite over adjacent. So y is the opposite side, x is the adjacent side, y over x. This is exactly the same way we defined it before. SOHCAHTOA still applies. And then for cotangent, it'll still be the reciprocal of tangent, so we'll call it x over y. Secant of theta will still be the reciprocal of cosine, so we'll call that r over x. And then cosecant of theta will be defined as r over y, which is the reciprocal of the sine. So the reciprocal relationships that I outlined before still hold. The guys that I'm pointing at are reciprocals of each other. Now, this definition will hold. These definitions, these trig ratios or trig functions, will hold if our angle is in the 3rd or 4th quadrant as well. So let's move this terminal side to the third quadrant over here. And then the angle becomes this guy that we want to look at. And this time, from anywhere on the terminal side, we can raise a perpendicular to create our triangle, our associated triangle, to the x-axis, straight to the x-axis. And then you see we formed another triangle. And then I can still call the side, we can still consider this side here, in this case horizontal, the horizontal side, we can still consider that the adjacent side. And so I would call that length x. The vertical length could still be considered the opposite side, y. And then this length here would be the hypotenuse. We'll call that length r. And then all of these definitions still hold. And then finally, I could create an angle in the fourth quadrant, so that now we're looking at theta as this big angle here. But again, you can raise a perpendicular in this case. Anywhere, just start from any point on the terminal side of the angle, create this right triangle. So this side here, again, we would consider that the adjacent side, call it x. This side, the vertical side in this case, would be called y, and we would still consider it the opposite side of theta. And then, of course, the hypotenuse is still r. And once again, these definitions, these ratios, are how we define the trig functions of that angle. So the beauty of this definition is that SOHCAHTOA holds. No matter if you have an acute angle, an obtuse angle, or an angle that's even bigger. All you have to do is make sure to coordinatize your angle, to put it in standard position, and either drop or raise a perpendicular, as I've shown you here, to create your triangle, and then you've got it. You can figure out what your trig ratios are. Now, it's also important to realize that for any point in the xy plane, you can create an associated angle. Well, any point except for 0, 0. So let's say you're given the point, I don't know, negative 5, 2. So that's a point in the second quadrant. Then for this point, negative 5, 2, you would associate it with an angle. If you're asked to do so, you would associate it with an angle that's created by letting the initial side coincide with the x-axis, and then shooting a ray from the origin right through that given point to create your angle. And so this point was negative 5, 2. And then we created the angle associated with it. And then it's going to be important to be able to find the trig functions associated with that angle, but you already know how to do that. You can drop a perpendicular, focus on this right triangle that we've just created, realize that the side adjacent to theta has a directed length of negative 5, and an opposite side of length 2. The hypotenuse we can get, well, we can call it r, but we can get it by Pythagorean Theorem. R squared is equal to 2 squared plus negative 5 squared. Or r squared equals, 4. Negative 5 squared is 25. So 4 plus 25 is r squared. So r squared is 29. And r is, we're always going to take the positive root for r. So just take the positive square root of both sides of that r squared statement and get r is the square root of 29. So if you wanted to put that in your picture, you'd have that. R is the square root of 29. And then, of course, if you're asked to find the 6 trig functions for that particular angle, then, again, as always, use SOHCAHTOA. Sine equals opposite over hypotenuse. In this case, that would be 2 over root 29. That's opposite 2 over hypotenuse, root 29. Cosine theta would be adjacent, negative 5, over hypotenuse, root 29. Tangent of theta, TOA, would be opposite over adjacent, or 2 divided by negative 5. To get cotangent, you just take the reciprocal of tangent, negative 5/2. To get secant, you just take the reciprocal of cosine, which would be root 29 over negative 5. And to get cosecant of theta, you just take the reciprocal of sine, which would be root 29 over 2. And you have all the trig functions associated with that point. Not only the angle associated with the point negative 5, 2, but all the trig functions of that angle you can obtain, which it'll be important for later on to be able to do that.